Question 1. Work out 8.46 divided by 0.15. So first thing I'm going to do, I'm going to multiply 8.46 by 100 to make it 846. And because I've multiplied the left hand side by 100 and I'm dividing, I'm going to do the same to the right hand side, even though sometimes I might not need to. And then I'm doing 846 divided by 15. So 846 divided by 15, 15, 30, 45, 60, 75, 90. So 15's into 84. 1, 2, 3, 4, 5. To get from 75 to 84 is a remainder of 9. 15's into 96. 1, 2, 3, 4, 5, 6. With a remainder to get from 90 to 96 of 6. And then 15's into 60. 1, 2, 3, 4. So it's 56.4. Because we're dividing and I multiplied both sides by the same thing, that is my answer. I don't need to reverse it. Question 2. Work out 7 3/8, subtract 2.5. Give your answer as a mixed number. So the first thing I'm going to do is convert each of these mixed numbers into improper fractions. So 7 multiplied by 8 is 56, add 3. So I have 59 over 8. Subtract 2 times 2 is 4, plus 1 is 5. So that's 5 over 2. Now I want a common denominator. I'm not going to change this fraction, but I am going to multiply this one by 4 because 2 multiplied by 4 gives me 8. So then 5 multiplied by 4 gives me 20. So now I can do 59 subtract 20. So I can subtract the numerators and the denominator stays as 8. 59 subtract 20 is 39 over 8. Now it asks for our answer as a mixed number. So this is currently an improper fraction because the numerator is bigger than the denominator. So I'm going to see how many 8's go into 39. 8, 16, 24, 32, 40. So 1, 2, 3, 4 8s with a remainder from 32 to 39 of 7 8s. So 4 and 7 8s goes on the answer line. Question 3. A cube has a total surface area of 150 centimetres squared. Work out the volume of the cube. So to work out the surface area of the cube, we would have found the area of one of the faces and then multiplied it by 6 because 6 faces of a cube would be equal in area. So the first thing I'm going to do is I'm going to divide 150 by 6 because this will then tell me what the area of one of those faces is. So 150 divided by 6, 6, 12, 18, 24, 30. Let's see if that's enough. So 6 is into 15, 1, 2. The remainder to get from 12 to 15 is 3. 6 is into 30, 1, 2, 3, 4, 5. So 150 divided by 6 is 25. So the area of one face of this cube is 25 centimetres squared. Now the faces are squares, so I can find the side length because it would be x times x. We've multiplied the length by each other to get 25. So the square root of 25 is 5. So that tells me that each side of this square or each edge of the cube is 5 centimetres. So now I can find the volume because I would do the area of the face of the cube times by the depth of the cube, which is going to be 5. So 5 times 5 times 5 is 125 centimetres squared. Question 4. The table shows information about the daily rainfall in a town for 60 days. So here we've got rainfall and we've got the ranges of values. Here's the frequency. Draw a frequency polygon for this information. So we've got our y-axis, the vertical axis that's frequency, and the x-axis is the amount of rainfall. So when we're plotting a frequency polygon, we need to plot with the midpoints. So we want the midpoints of these ranges. So halfway between 0 and 5 is 2.5. Between 5 and 10, 10 and 15, 15 and 20, 20 and 25. So we're going to go along to the midpoint, up to the frequency and mark a cross. Now, if you were struggling with the midpoints, you could add the two parts of the range together. So 20 plus 25 is 45, and then half that to get your midpoint. So along to 2.5 up to 8. So we'll just be careful with our scale. So here's 5, so that must be 2.5. That must be 7.5, etc. Just to make sure we're plotting it in the right place. So along to 2.5 up to 8. Along to 7.5 up to 24, along to 12.5 up to 13, 17.5 up to 11, and then 22.5 and up to 4. So with frequency polygon, we're going to join those points together with straight lines. And then it's important because, just organise this paper, because we're drawing a frequency polygon, a polygon is a 2D shape. This is not a shape at the moment, it's just a lot of line segments connected. So we need to make sure we join the first and the last point directly as well, and that forms that polygon shape in our graph. Question 5. So we have the universal set that contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Set A are all the odd numbers that are in this set here, and B are all the square numbers in this set. Part A, complete the Venn diagram for this information. So we have a circle for A and a circle for B. The intersection in the middle is where we put any values that appear in both A and B. So let's have a look. A is odd numbers. So let's have a look for the odd numbers in this list. So we have A, 1, 3, 5, 7 and 9 are odd numbers. B is square numbers. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, so that's too big. So what we can see here now is the numbers that have pink and yellow are both A and B. So 1 and 9 need to go in that intersection in the middle. Anything that's just pink is going to go in the A circle here. So 3, 5 and 7. Anything that's just yellow, 4, is going to go in the B circle. And anything that's not highlighted, so 2, 6, 8 and 10, go on the outside of the circles like that. All values in that set need to be included, they just might not be within these circles. Okay, a number is chosen at random from the universal set. Part B, find the probability that this number is in the set B complement. So that little dash there is complement, and it means not in set B. So we're looking for anything that's not within the B circle. So anything within that we're not including. So 1, 2, 3, 4, 5, 6, 7 numbers are not in B, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in total. So the probability that the number is in set B complement, that symbol is complement, so not in B, is 7 out of 10. Question 6. The scatter graph shows information about the ages and weights of some babies. So we have the weight on the vertical axis and the ages in months on the horizontal axis. Part A, describe the relationship between the age and the weight of the babies. So it's asking us to describe the relationship, not the correlation. So we have to explain what's happening. So what we'll notice is all of the points are moving in an upwards direction. So they're moving in an upwards direction in a positive direction. So that tells us that there's a positive direct relationship between these two things. So as the age increases, so does the weight of the baby. So that's how we're going to describe it. So as age increases, so does the weight of the baby. Which makes sense, right? The older a baby gets, the more weight it's going to put on as it's growing and developing. So another baby has a weight of 5.8 kilograms. Part B, using the scatter graph, find an estimate for the age of this baby. So to be able to estimate from a scatter graph, we need a line of best fit. And what's important is your line of best fit follows the trend of the data. So if I drew a line like this across here, it's not following the trend of that data, so it wouldn't help me in estimating anything. So when we're doing this, we want roughly an average line. So we want roughly an equal number of points on either side. It doesn't have to be an exact science, and it doesn't necessarily have to go through any points, all of the points. It doesn't matter, as long as we have a line that follows the general trend of the data that we can use to predict from. So we've got a weight of 5.8 kilograms. So this is weight here. So I'm going to find 5.8. So 4, this is 5, so this is 5.8. And what I'm going to do is I'm going to read across to the line that I've just drawn, my line of best fit, and then read down from my line of best fit. And then I'm going to estimate this point here. So that's 2, 3.2, 4, 3.5. And it is an estimate. So if you were reading this off this question, you might get a slightly different answer depending on where you drew your line of best fit. But the mark scheme will have a range of values that you're allowed to be within. So they allow for that slight difference in your line of best fit, as long as you're trying to follow that trend of the data. Question 7. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. So if that 20% adds £240, then that 20% must be equal to the £240. We're trying to find the original price before the increase, so we're wanting what the original 100% would be. Well, 100 divided by 20 is 5, so if I multiply by 5, that will tell me the original price of the holiday. So 5 multiplied by 0, 5 multiplied by 4, 5 multiplied by 2. So the price of the holiday before the increase was £1,200. Question 8. The diagram shows a solid cylinder on a horizontal floor. So this is the cylinder. It's got a height of 40 centimetres. We've been given the pressure equals force divided by area formula. So the cylinder has a volume of 1,200 centimetres cubed and a height of 40 centimetres. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. So we're working out the pressure. We know the force, so what we're missing is the area. So we need to find the area of this face here, this circular face that is on the floor. We've been given the volume. To find the volume, we would find the area of this circle and then multiply it by the height. So if we reverse that, if we do 1,200 divided by 40, that will tell us the area of that face of the cylinder. So 1,200 divided by 40. Well, I can divide top and bottom by 10. So then I'm doing 120 divided by 4, which makes my life a little bit easier. So 4's into 12. 4, 8, 12, 1, 2, 3. No remainder, so the answer is 30. So the area is 30 centimetres squared. The force is 90 newtons. So we can now find the pressure, because pressure is force divided by area. Again, we can divide top and bottom by 10. Then we're doing 9 divided by 3, which is 3. So the pressure is in newtons per centimetres squared, because we've got centimetres squared and newtons. So the answer is, make sure you can see it, 3 on the answer line. Question 9. Use these graphs to solve the simultaneous equations 2 subtract 2y equals x. So 2 subtract 2y equals x is this line here. And then 2y equals 3x subtract 22, which is this line here. So to solve simultaneous equations, if we draw the two lines, the two graphs, where they intersect tells us the solutions. So the x coordinate will be the x solution and the y coordinate will be the y solution because we need an x and a y for simultaneous equations. So the x coordinate is 6 and the y coordinate is -2. Question 10. Here is a pentagon, so five-sided shape. Angle AED, so this angle here is 4 times angle ABC, this angle here. Work out the size of angle AED, you must show all of your working. So we've been told that AED is 4 times this angle, so if we call this angle X, AED must be 4X. So angles inside a pentagon. So we want to know what the angles inside a pentagon would sum to. So we're going to do the number of sides subtracted by 2 multiplied by 180 for the sum of the interior angles. So we've got 5 sides, which is 3 times 180, which is 540 degrees in total. So let's form an equation now to solve, knowing that all of these angles should add up to 540. So we have 110 plus 135 plus 4x plus 120 plus x should all equal 540. Positive 4x add x. Remember, collecting like terms, it's the signs in front that are important. Positive 4x add x is 5x. 110 plus 135, that's 245. And then if we add the other 120, 365. So 5x add 365 equals 540. So now we're going to subtract 365 from both sides. And then we're going to divide by 5. Fives into 17, 1, 2, 3. 15 to 17 is remainder 2. 5s into 25, 1, 2, 3, 4, 5. No remainder. So x is 35. They want the size of angle AED. We said the angle AED was 4x. So 4x is angle AED. We've just worked out that x is 35. So 4 times 35 is AED. Let's do some working out. 35 times 4. 4 times 5 is 20. 12. 140. So AED equals 140 degrees. And we're going to pop that on our answer line. Question 11. Write this expression in the form ax to the power of b, y to the power of c, where a, b and c are integers. So we're going to use our laws of indices to simplify this further. So I'm going to start with the numerator. So 6 squared is 36, x to the power of 5 times 2, y to the power of 3 times 2, because that bracket is a power of a power rule. So that's the numerator simplified. Let's do the denominator. So 3 times 4 is 12. X to the power of 2 multiplied by x to the power of that invisible 1 is x to the power of 3, because we add the powers when we're multiplying. Y to the power of 7 multiplied by y to the power of -3 is y to the power of 4. Again, 7 plus -3 is 4. Now it's a case of simplifying. So 36 divided by 12 is 3. X to the power of 10 divided by x to the power of 3. We're dividing, so the law of indices for division says we subtract the powers when the base number's the same. So that becomes x to the power of 7, because 10 take away 3 is 7. And then y to the power of 6 divided by y to the power of 4 becomes y squared, because 6 take away 4 is 2. And then that's our expression simplified. And A is 3, B is 7 and C is 2. All of them are integers, all of them are whole numbers. Question 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. So this is the first game, this is the second game, the branches dependent on the first game. So if they win, and then they win or lose the second game. If they lose the first game, win or lose the second game. Find the probability that Martha will lose at least one game. So by losing at least one game, we're not interested in win-win because they haven't lost anyway, but we can win the first game, lose the second game. So win the first, lose the second. So this is win-lose. And then we could lose the first, win the second. That's 3/8 multiplied by 2/9. Or we could lose the first and lose the second, because it says at least one game, not just one game. So if we lost both games, it would be 3/8 multiplied by 7/9. So let's work these out. Multiplying fractions, we do numerator multiplied by numerator, and then denominator multiplied by denominator. So that's 35 over 8 times 9, 72. And then 3 times 2, that's 6 over 72. 3 times 7 is 21 over 72. Now we need to add these probabilities together. Now fortunately we have a common denominator of 72. It's just simply a case now of adding the numerators. So 35 plus 6 plus 21, so that's 11, 12. So we've got a probability of 62 out of 72 that Martha will lose at least one game. You don't have to simplify that any further, just pop it on the answer line. Question 13, y is directly proportional to x. So y is directly proportional to x. Y is 24 when x is 1.5. Work out the value of y when x equals 5. So this is the y is proportional to x, directly proportional to general form. So we can also say that y equals kx, k being the constant of proportionality. So we need to work out what k is to be able to do anything else with this problem. So they've given us a corresponding y and x value. We're going to substitute those in. So when y is 24, x is 1.5. So k is equal to 24 divided by 1.5. So now we need to do 24 divided by 1.5. So if I multiply that by 10, it becomes 15. Have to do the same on the other side because we're dividing. So I'm doing 240 divided by 15. 240, 15, 15, 30, 45, 60. 15's into 24, 1. To get from 15 to 24, it's a remainder of 90. We need to go a bit further with these then. There we go. 1, 2, 3, 4, 5, 6. 6 15s into 90. So 240 divided by 15 is 16. So 24 divided by 1.5 is also 16. So we can rewrite this as y equals 16x. So this is the form that we're going to use now. Work out the value of y when x is 5. So we're going to substitute 5 in here for x. So y equals 16 multiplied by 5. 16 multiplied by 5. 5 times 6 is 30. 80. So when x equals 5, y equals 80. Question 14a. Write 1 over 16 in the form 4 to the power of n, where n is an integer. So we need a base number of 4. So I'm going to first of all figure out what 16 as a power of 4 would be. Well, I know that that's 4 squared because 4 times 4 is 16. So I'm going to replace 16 in this fraction with 4 squared. So 1 over 4 squared. Now, the problem we have here is we've got the reciprocal of 4 squared. If we have the reciprocal of 4 squared, 1 over 4 squared, that means we must have started with a negative power. So it must be 4 to the power of negative 2. So n is negative 2, which is an integer, a whole number. So 4 to the power of negative 2. Part B, work out the value of 8 to the power of 5 over 3, subtract 9 to the power of 3 over 2. So there are multiple ways you could do this. I'm going to write 8 as a smaller number as a power. So I know that 8 equals 2 to the power of 3. I also know that 9 equals 3 to the power of 2. So I'm going to replace 8 with 2 to the power of 3 times that power of 5/3. And I'm going to replace 9 with 3 to the power of 2 times that power of 3 over 2. 3 times 5/3 is 15 over 3. 2 times 3 over 2 is 6 over 2. 15 divided by 3 is 5. 6 divided by 2 is 3. 2 to the power of 5. 2 times 2 times 2 times 2 times 2. It's 4, 8, 16, 32. Subtract 3 to the power of 3. 9, 27. So we're doing 32 subtract 27, which is 5, and that goes on our answer line. Question 15. The equation of line L1 is y equals 2x subtract 5. The equation of the line L2 is 6y add kx subtract 12 equals 0. L1 is perpendicular to L2. Find the value of k you must show you're working. So the first thing I'm going to do is I'm going to rearrange L2 so that it's in the form y equals to start off with. So 6y equals, I'm going to subtract kx, and I'm going to add 12. So 12 subtract kx, and then I'm going to divide by that 6. So y equals 2 subtract k over 6 x. So this is L2, and L1 is y equals 2x subtract 5. Now, if L1 is perpendicular to L2, then it has the negative reciprocal gradient. Okay, so if the gradient of L1 is 2, y equals mx plus c, and the m is the gradient, then the gradient of L2 must be negative a half because it's the negative reciprocal. At the moment, I have negative k over 6. So if negative k over 6 is equal to negative a half, what must k be? Well, we can multiply by negative 6, or we can see if we can spot what would happen. If I want this to be a fraction over 6, I would multiply it by 3. So it would be minus 3 over 6. So we can directly compare what k should be. So k equals 3. Question 16. Here is a sphere. So we have a sphere and we've been given the formula for the surface area of a sphere, which is 4 pi r squared. 3/8 of the surface area of this sphere is 75 pi centimetres squared. Find the diameter of the sphere. Give your answer in the form a root b, where a is an integer and b is a prime number. So these are the important things we need to check in our answer at the end. So if 3/8 of the sphere is 75%, so if 3/8 is 75 pi, 1/8 would be divided by 3, which is 25 pi. So the whole surface area times by 8, because I'm working in 8, so 8 over 8, which is the whole thing. 25 times 8, 8 times 5, 40, 200. So the whole surface area, so total surface area is 200 pi. To find the surface area, we do 4 pi r squared, and that would give us an answer of 200 pi. So let's divide both sides by pi, so 4r squared equals 200. We're aiming for the diameter. This is going to give us the radius. So let's get the radius first and see where we're at. So let's divide by 4. And then we just want the radius itself, so the radius is the square root of 50. Now, if the radius is the square root of 50, we want the diameter. The diameter is double the radius. So the diameter is 2 root 50. However, a is an integer, b is a prime number. 50 is not a prime number, so we need to simplify 2 root 50 further. So we can simplify this as 2, and then 50 can become 2 times 25. And then, which will become 2 times 5 root 2, which will become 10 root 2. Let's check this. A is an integer, b is a prime. 10 is an integer, 2 is prime, so we're going to write our diameter as 10 root 2 centimetres. Question 17. Make x the subject of the formula. So we have this formula here and x appears on the numerator and the denominator. So we're going to have to do some expanding and rearranging to start off with. So let's expand the numerator. So 4 times 2x is 8x, 4 times negative 7, negative 28. Now I'm going to multiply by the denominator. So 5x plus 3 multiplied by y equals 8x subtract 28. I'm now going to expand this bracket. So I have 5xy plus 3y equals 8x subtract 28. I'm making x the subject, so any terms that have x in, so it appears here and here, I want them to be on the same side of this equation. So I'm going to subtract 8x over to this side, and then I'm going to subtract 3y over to this side. Now I can factorise for x. So if I factorise for x, I get 5y minus 8 inside the brackets, and then I only have one x term, which means that I'm going to end up with x equals eventually, which is what we want. And then I'm going to divide by the bracket. So minus 28 subtract 3y over 5y minus 8. And that... oh, it's not y equals, is x equals. Question 18. 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480 pence. So 7 lots of carrots plus 5 lots of tomatoes is 480. The cost of 1 kilogram of carrots to the cost of 1 kilogram of tomatoes. So kilogram to carrots is in the ratio, carrots to tomatoes, sorry, is in the ratio 5 to 9. Okay, work out the cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes. So we're trying to find the value of C and T is what we're trying to do here. So I've got an equation here in terms of C and T, but let's see if I can make an equation in terms of C and T out of this ratio. So C divided by T is equal to 5 divided by 9, which means that 9C is equal to 5T. Well, if 9C is equal to 5T, I can replace 5T in this equation here with 9C. So if we go to here, 7C plus 9C is equal to 480. 7C plus 9C is 16C. So then if I divide by 16, C is equal to 30. Okay, now I know that C is equal to 30. Let's go back to this original equation. So 7 times 30 is your 7C. Add 5T is 480. 7 times 30 is 210. Plus the 5T. Let's subtract the 210. So 5T is 270. Divide by 5. So T is 270 divided by 5. So that's 5, remainder 2. That's 54. So 1 kilogram of carrots is 30 pence. 1 kilogram of tomatoes is 54 pence. Question 19. The menu in a restaurant has starters, main courses and desserts. There are 5 starters, 12 main courses and X desserts. There are 420 different ways to choose 1 starter, 1 main course and 1 dessert. Work out the value of X. Okay, so it's a combinations question. To find out how many different ways there are to choose 1 of each, I would have done 5 starters multiplied by 12 mains multiplied by however many desserts we have. Okay, we don't know what X is, but that would have given me the answer of 420 different combinations. So if I simplify this a little bit, 5 times 12 is 60. So 60x is equal to 420. So now I can solve that for X. So I'm going to divide by 60. So X equals 420 divided by 60. Divide numerator and denominator by 10. So I'm doing 42 divided by 6. So 6 is into 42. 6, 12, 18, 24, 30, 36, 42. 1, 2, 3, 4, 5, 6, 7. So X is equal to 7. Question 20. For x is greater than or equal to 0, the functions f and g are such that f of x equals 3x, add 4, g of x equals the square root of x, add 2, all divided by 5. Part A, find the inverse function for g. So this one here, we're going to find the inverse function. So I'm going to write it as y equals root x plus 2 over 5. And I'm going to rearrange it for x to start off with. So I multiply by 5, subtract 2, and then I'm going to square everything on this side. So I can say that the inverse of g of x is 5x minus 2 all squared. I've simply replaced the y with x. Writing it that way just made it easier for me to figure out. Now it says solve g f of x equals 3. So this is a composite function. So I'm substituting the function f into the function g wherever there's an x value. So g f of x is equal to the square root of whatever x is, add 2 all over 5. F of x is being substituted in. This is f of x. So we're going to have the square root of 3x add 4, add 2 all over 5. Now it tells us that that equals to 3 and we need to solve it. So 3x plus 4 add 2 all over 5 equals 3. Multiply by 5, so the root of 3x add 4 plus 2 is equal to 15. Subtract the 2. So that equals 13. We're going to square it. So 3x add 4 equals 169. Then we're going to subtract 4. And then we're going to divide by 3. So 165 divided by 3. 3 is into 16 is 5, remainder 1. So x is 53. Question 21. A, B and D are points on a circle with centre O. So we've got A, B and D on the circumference of the circle, and then we've got O at the centre. CDE is the tangent to the circle at D. So CDE is a straight line forming a tangent to the circle at the point D. Work out the size of the angle ADC. So ADC, we're looking for this angle here. Write down any circle theorems that you use. So the first thing I'm going to do is spot angles that I can work out nice and easily. So I know that angle A is half the angle at the centre, because if angle A was stretched around here, we would have like an arrowhead shape, and the angle at the centre is twice the angle at the circumference at the circle. So I'm going to write that down. Angle at the centre is twice the angle at the circumference. So that tells me that angle BAD, so angle BAD is equal to 64 divided by 2, which is 32 degrees. So I'm going to mark that there on my diagram. So what I'm doing is I'm going to work out as many angles as I can until I get to this point here. So next thing, this here is a small triangle. Even though it's inside a circle, it's still a triangle. I know that angles in a triangle add up to 180, so I can find this angle here. So I'm going to do 180, subtract 51, subtract 32. So 180 take away 51 is 129, and then 129 take away that 32. It's 97. So this angle here is 97. I'm not going to write down angles on a straight line sum to 108, angles in a triangle add to 180, because it only wants me to write down any circle theorems. And it's one of the angle facts that I know. Now I know vertically opposite angles are equal. So this angle must be 97. And then we have this small triangle here. So I'm going to add these two angles together and subtract it from 180 to find this angle. And there's a reason for that, and I'll tell you that shortly. So 180 subtract 97. Is 83, and then I need to subtract the 64. is 19. So this angle here is 19. Now, there's another circle theorem that I'm going to use. So we have this tangent to the circle at D here, at point D. And tangents to a circle are perpendicular to the radius, which is this line OD. And they form a 90-degree angle. So I'm going to write that down. Tangent to a circle is perpendicular to the radius. So now that I know from here to there must be 90 degrees, I know this part is 19, I can now find out this missing angle that I'm looking for. So I'm going to do 90 subtract 19. So 90 subtract 19 is 71 degrees. This is the angle ADC, because this 71 here plus this 19 forms this 90. So that's my answer, 71 degrees. Question 22. A, B, C, D, E, F, G, H is a cuboid. So this is our cuboid and the vertices are labelled with the letters. AF is 6.8 centimetres. So AF, 6.8 centimetres. I'm going to mark that on my diagram to help me out here. FC is 13.6 centimetres. So from F to C, is 13.6 centimetres. Work out the size of the angle between FC and the plane ABCD. So the plane ABCD is here, and they want to work out the size of the angle that this line makes with this base here. So what I'm going to do is draw the diagonal A to C, because that shows me where we would hit the plane. So it's this angle here that we're looking for. Now what it's important to do with 3D shapes is recognise those right angle triangles. So I'm going to work with this triangle here. Yes, it doesn't look ultimately like a right angle, but it is, because AC is flat, it's horizontal at the base of that shape. So this is actually a right angle. So we're trying to find this angle. We have two sides of this right angle triangle. So we're going to use right angle trigonometry. So we have the opposite and the hypotenuse. So if we're dealing with opposite and hypotenuse, we're dealing with the sin ratio. So let's substitute what we know. So sin x is equal to the opposite over the hypotenuse. X is the angle that we're looking for. So sin x is equal to the opposite 6.8 over the hypotenuse 13.6. Now the thing here is that we don't have a calculator. This is a non-calculator paper, so we're going to have to work with exact trig values to find that angle. So what I want to do is simplify this fraction and see what value it gives me. So if I'm going to simplify 6.8 over 13.6, let's divide it by 2. 13.6 divided by 2, 6.8. Okay, let's do it again. Let's divide by, put them in half again. So 1.5, 1.7 over 3.4. Now 1.7 is half of 3.4. So that simplifies to a half. So actually, sin x equals a half. Now we need to think about those exact trig values. However you generate those trig values is up to you. So if we were doing a table for sin, we have 0, 30, 45, 60 and 90 degrees. We would have root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. So let's simplify this. So root 0 over 2, this becomes 0. Root 1 over 2 becomes a half. Root 2 over 2 stays as it is. So does root 3 over 2. Root 4 over 2 becomes 2 over 2, which is 1. Now we have sin of an angle is a half. This is a half here in our table for our sin values. So that x must be equal to 30. So sin of 30 is equal to a half. so x is equal to 30 degrees. We're going to pop 30 on our answer line there. Question 23. So we've got a fraction subtraction, but it's got thirds in there. So they want us to write this calculation in this form where a, b and c are integers. So what I'm going to do to start off with is I'm going to rationalise both of these fractions. So if I've got 3 root 3 over 4 minus root 3, I'm going to multiply it by 4 plus root 3 on top and bottom. I'm rationalising it because I don't want to deal with those messy thirds on the bottom for my denominator. So 3 root 3 times 4 is 12 root 3. 3 root 3 times root 3 is positive 3 root 9. And then on the bottom we'd have 4 minus root 3, 4 plus root 3. So let's simplify this a little bit more. 12 root 3. And then root 9 is 3, so that's plus 3 times 3, which is 9. And then 4 times 4 is 16. 4 times positive root 3 is positive 4 root 3. Negative root 3 times 4 is negative 4 root 3. And then negative root 3 times positive root 3 is negative 3. This is what we wanted. We wanted those terms to cancel out at the bottom to rationalise it, hence the opposite sign being used here. So this is 12 root 3 add 9 over 16 subtract 3, which is 13. I'm going to do the same for 2 root 3, so let's do that here. So I'm going to multiply numerator and denominator by root 3, so that gives me 2 root 3 over root 9. Root 9 is 3, so it's 2 root 3 over 3. So I'm going to rewrite these as a subtraction, so it's this one first. 12 root 3 add 9 over 13, subtract 2 root 3 over 3. Subtracting fractions, we want a common denominator. So I'm going to multiply this fraction by 3, so that's 36 root 3 plus 27 over 39. And then I'm going to multiply this fraction by 13, so that's 26 root 3 over 39. We have a common denominator, so we can write it as 1 fraction, and then we're going to start simplifying. So 36 root 3 subtract 26 root 3 leaves me with 10 root 3. The plus 27 here is going to remain on the top, and then we've got 39 on the bottom. I can't simplify this any further because there isn't a common factor of 10, 27 and 39 other than 1. So this is my final answer, but I'm going to check. A, B and C need to be integers, 10, 27, 39. Good, I'm happy with that, so I'm going to carefully copy that on my answer line. Question 24. Find the set of possible values of x for which 4x squared subtract 25 is less than 0 and 12 subtract 5x subtract 3x squared is greater than 0. You must show all your working out. So the first thing I'm going to do is find the possible solutions for 4x squared subtract 25 is less than 0. So I'm going to start at this stage with just an equals sign there. I'm going to come back to that inequality and how it impacts the question shortly. I'm going to factorise to solve this equation. So this is a difference of 2 squares. 4 is a squared number, 25 is a square number. So this would be 2x subtract 5 and 2x add 5. Square root of 4 is 2, square root of 25 is 5. We want a negative and a positive so that the x terms in the middle cancel out when we expand those brackets. So we have 2x subtract 5 equals 0, so 2x is equal to 5 and x equals equal to 5 over 2. That's that first bracket solution. Do the same with the next bracket. So 2x equals negative 5, so x equals negative 5 over 2. So I have 2 solutions for this graph here. Now it's actually this less than sign, so x is less than 5 over 2 and x is less than minus 5 over 2, but I'm going to have to do some work with those shortly. I'm going to show you what I mean by that. I need to figure out if it's still a less than or equal to sign. We'll do that shortly. Now I'm going to deal with this one, but I don't like the fact that I have a negative x squared. So I'm going to move everything over to the right hand side, so that becomes 3x squared plus 5x subtract 12. But because I've moved everything across this sign, it then becomes a less than 0. The sign flips, okay, because I've changed this sign here. Now I'm going to factorise. So I'm going to do splitting down the middle method. It's entirely up to you how you do this. So 3 times minus 12 is minus 36. Two numbers that make 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. A difference of 5, so I'm going to go with these two. So we have 3x squared plus 9x subtract 4x, because 9x subtract 4x gives me 5, and it's me using the 9 and the 4 to make the 36. And then I've got subtract 12 on the other side. Split it down the middle. Let's factorise this side. So we have minus 4x plus 3. I want the bracket to match on this side, so I need a 3x there. 3x subtract 4 on the outside of the brackets is one of my brackets, and then the x plus 3 repeating bracket is the other. So 3x minus 4, 3x is 4x, so that's 4 over 3, and then x plus 3. Okay, so I've got these solutions here, but now I need to figure out what symbols we're going to use. So I'm just going to roughly sketch a quadratic graph, and I've sketched a U shape because that's a positive x squared, and I changed this to be a positive x squared as well. So if these are the two roots of the equation, if I'm dealing with these solutions here, so negative 5 over 2 would be this root, and 5 over 2 would be this root. Now I want less than 0, so I want all of the values that are included less than 0 for these solutions, which are those ones, because they're below the x-axis, which means actually I want any x values that are greater than negative 5 over 2, but less than positive 5 over 2. Okay, so if I was going to do the same with these two solutions that we found here, again, I'm dealing with less than 0, and I've got 4 over 3 and a negative 3. So the negative 3 root would be there, the 4 over 3 root would be there. So again, I'm wanting x is greater than negative 3, but less than 4 over 3, because I want to include these solutions here that are below 0, below the x-axis. So now I'm finding the set of possible values that satisfy this inequality and this one. So let's look at them. The lowest value that x has to be greater than for this inequality is negative 5 over 2, which is negative 2.5. The lowest value that this one has to be greater than is negative 3. So if this has got to be greater than negative 2.5, then negative 2.5 must be the smallest value that satisfies both of them. Okay, now let's look at the extreme values. So we want, with this equation, we want x to be less than 5 over 2, so less than 2.5. And with this one, we want x to be less than 4 over 3, which is 1 1/3, so 1.3 recurring. So yes, this needs to be less than 2.5, but this one has got to be less than 1.3 recurring. So this is going to be our maximum value that satisfies both, because anything from this point and below is less than 2.5. So we're going to have less than 4 over 3 there. And then we're just going to pop this on our answer line. So 5 over 2, 4 over 3.